Hi everyone, welcome back. So what we're going to take a look at here in this lesson is some properties of even and odd functions when you're integrating. So we have a couple rules here. Now even functions are functions with even powered exponents, okay, and odd are odd power exponents. So I want you to take a look at the pictures here for me first. So let's say that we have this function f of x equals x squared, okay? So we have negative a here and positive a here. Now, they have to be the same value, so negative 1 and positive 1, negative 2 and positive 2, okay? Otherwise, this does not work. So the negative a and the a have to be the same values, just one positive and one negative, okay? Now, remember that integrating is finding an area under a curve, right? So if you were to carry this line up, say from here, from negative a, okay, and you were to shade this part in, you can see, or somewhat, my picture isn't all that accurate, but this amount of area will be the same exact as whatever this amount of area is. So one of these, okay, is enough for you to get your answer, because once you know what one of these is worth, you just double it. So take a look at this formula. So here's the negative a to positive a. You have your function in there. Notice that it's the same thing as double what we just saw from 0 to a. In other words, they're talking about the positive end here. Okay, so that's a really nice shortcut if you know how to use it, which I'm going to show you how to do. If it's an odd function, like our f of x equals x cubed, let's do that again. So we're going to follow negative a to our function, shade it in. Follow positive a all the way up to our function, shade that in. Now, what's a little bit different here is that whatever area is here is negative because it's below the x-axis. And the area that's here is positive, but they take up the same amount of area. So they actually cancel each other out. So whenever you have a negative value and a positive value here, okay, remember they have to be the same, negative 1 or positive 1, negative 2, positive 2, etc. Your answer will always be 0 because those areas cancel each other out. So let's take a look at a couple examples to see how this works. All right, so first we have the definite integral from negative 2 to positive 2, and notice that they are the same value, just one positive, one negative, so I know I can use this rule, okay? Now, the next thing to do is figure out if it's odd or even. And the only part that really matters is the leading term. So these guys are going to need to be multiplied. The 1 doesn't matter. And the reason is because it's smaller than an x squared term. Okay? We're looking for the biggest exponent that there is. The leading exponent will always tell you if it's odd or even. X squared times x squared is going to give me an x to the 4th, which means it's an even function. So we're going to rewrite this. Okay? Now remember our rule from here that if it's even, we're going to do double of just 0 to our positive bound. So let's rewrite this as 2 times the integral from 0 to 2, and then x squared times x squared plus 1 dx. Now, we do not need to do any kind of fancy substitution for this problem, okay? I'm just going to distribute these and carry on. So I'm going to do 2 definite integral from 0 to 2, and then x squared times x squared is x to the 4th, x squared times 1 is just x squared, and then dx. So we're going to integrate and then evaluate. So 2 times, let's see what we get. So we're going to add 1 to the 4, divide by the sum. That's going to give me 1/5 x to the 5th. And then add 1 here, divide by that sum, so plus 1/3 x to the 3rd. And then vertical bar from 0 to 2. So remember our fundamental theorem of calculus says to plug in 2 first. So we're going to do 2, and I'm going to use a bracket here, 1/5 times 2 to the 5th power, come on pen, plus 1/3, 2 to the 3rd power, And notice that we actually do not have to plug in 0. And the reason is because when I plug in 0 here and in here, I will get 0. So I don't have to do this process twice. So let's continue what we're doing. So we're going to do 2, and then 2 to the 5th power is 32. So that's going to give us 32 fifths. And then 2 cubed is 8 times a third. That's going to be 8 thirds. And back to some basic math here. We need some common denominators here. It's going to be 15. So let's go ahead and keep going. We've got 2. And then we're going to have to multiply this by 3, which is going to give us 96 fifteenths. And then for the next one, we're going to have to multiply this guy by 5. That's going to give us 40 over 15. So now all we have to do is add those together and then multiply it by 2. So 96 and 40 is 136 fifteenths. And then we multiply 136 by 2, which is 272 over 15. And of course you want to see if that can be reduced, and it cannot. There are no common factors, so that's our final answer. Let's take a look at a couple more. Okay, so let's take this example. So we're going to use the integral from 0 to 2 of x squared dx, having a value of 8 thirds, to evaluate the following. Now what's important to note is what kind of function x squared is. Is it even or is it odd? And it's even, so it's going to have, just to refresh your memory, it's going to have this property, okay? We're going to get to just do double of whatever 0 to a is. In other words, the value of 0 to a is the same as from -2 to 0 or -1 to 0, whatever it may be. So taking a look at this, letter A, we have the definite integral from -2 to 0 of the same exact function. Now, since this function originally is from 0 to +2, okay, this is the same thing in the other direction, 0 to -2. And what we know about even functions is that they will always have the same value on the right as they do the left, as long as these values match, which they do. So since that's true, then our definite integral from -2 to 0 of x squared is also 8 thirds. It is the same exact thing. All right, so the next one, we have the definite integral from -2 to +2 of x squared dx. Now we have one different thing in here, and that's the -2, okay? Which means that we can use our shortcut and say that it's just double of whatever the integral is from 0 to +2 x squared dx. Now we have the value of that integral already, but we need to carry over the 2. So it's going to be 2 times whatever 8 thirds is, which is 16 thirds. So no integrating necessary if you know this rule and you have a simple function, which is really helpful. All right, now this one here looks like we have a negative sign, which I'm going to put on the outside of my integral. And then we have from 0 to 2 of x squared dx, which is going to be a negative, and then times whatever that value is, which we know to be 8 thirds. So our final answer is just -8 thirds. And then the last one. So same kind of situation. I'm going to take the 3 and put it on the outside. And this is still from -2 to 0 of x squared dx. And we already know the value of this integral from example A. So I know that this whole part is 8 thirds. So I'm going to do 3 times 8 thirds. And that's going to give me 24 over 3, which is the same thing as 8. So there we go. Okay, so just one more example and then we'll be done. So we're going to write this integral as the sum of the integral of an odd function and the integral of an even function, and then we're going to evaluate that function. So what we want to do first is pick out all of the odd parts of this function. So that's x cubed and x to the first. So those are going to be paired together. And then our even parts are x to the second power and x to the nothing, so 0. So we're going to rewrite this as two separate integrals. I'm going to do the odd one first. So that's x cubed minus 2x dx. And then we are going to subtract, actually, no, sorry, we're going to add, my apologies, from -4 to +4 of 6x minus 3 dx. So now what we're going to do is use our rules to help us out here. So for the odd function, remember that if these two are the same and you have an odd function, our automatic result will be 0. So this entire part just canceled completely from our problem. Pretty nice. Now the next part, since it's odd, since this part is even, and I forgot the squared over here. I'm going crazy. There we go. We are going to change this lower bound to 0 and put a 2 on the outside of our integral instead. So let's do that. So we're going to do 2 and then integral from 0 to 4. That's a terrible integral. I'm sorry, my pen is having some issues. 6x squared minus 3 dx. So we're going to go ahead and start our integration process. So we're going to add 1 here, divide by 3. Now this 6 over 3 right here will actually reduce to a 2. So I'm just going to write a 2 here and then x cubed. And then our next part has an x to the 0. Okay, that's an x to the 0 that's right here. So when we add 1 to it, it's just going to be x to the first, or x. Now dividing by 1 is not going to change anything either, so minus 3x. And then we're going to use our vertical bar from 0 to 4, and we're going to evaluate. So we're going to do 2 first, open a bracket, and we're going to plug in our 4. So 4 goes in first here. 4 cubed is 64, and 64 times 2 is 128. And then minus 3 times 4 is just 12. And this is a special case because when I plug in 0 to here or here, I will just get 0 back. So I don't have to plug this in. Now that's not going to be the case all the time, so just be wary. So let's go ahead and evaluate all of this. And our final answer is 232. So there we go. Some shortcuts for even and odd functions when integrating. Thanks for watching.